Good morning, everybody, and thank you for joining us today. Today's webinar is on operational theory, software overview, and method development software basics for the QuickTrace M8000. We will be taking questions at the end of the webinar, so feel free to submit those throughout the presentation. Okay, Jeff, I'm going to turn it over to you.
Good morning, and thank you for joining the webinar today. As Shelley stated, we are going to go over software theory and some basic tricks in method development through the software. So a little bit about us to start out, if you're not familiar with Teledyne Leeman Labs. We sell a number of instruments that are satisfy mercury analysis needs, and we provide a choice for customers on different techniques. And our mercury systems are based on the mature time-honored technique of cold vapor atomic absorption spectroscopy. And we also have with or without gold enrichment or gold amalgamation with some of these instruments. The Hydra product and the QuickTrace product lines are designed to cover a variety of techniques and digest matrices, but they meet the stringent requirements of the US EPA and European norm methodologies that they're built around. Some of our customers include laboratories in environmental, academics, and petrochem, food, to name a few. Basically, if there's a laboratory with a bench, they would be one of our customers, and we have numerous instruments in the field, and we've been in this business since 1991 between the Hydra and the QuickTrace products. So a little bit about the atomic absorption. Atomic absorption spectroscopy for cold vapor was introduced in 1968 by Hatch and Ott on the heels of the first commercially available atomic absorption spectrometer. And so in their work, they described a device where you could introduce mercury in the 2+ state and then reduce it to the ground state, and then from there would go into an optical cell for concentration determination. So this technique very quickly then became the technique of choice for mercury determination, and shortly after following that, a decade or so later, cold vapor atomic fluorescence spectroscopy came on board. And in the late 80s, you could commercially buy detectors for atomic fluorescence, and in 1996 was when the US EPA introduced the first 1631 method, which was 1631 Rev A, and that was finalized into Rev E a few years later. Some of the highlights for the M8000 cold vapor atomic absorption fluorescence system. It's either AF or AF gold. It has a patented gas liquid separator, superior dynamic ranges. It employs the QuickTrace software, and we have some reduction reagent costs, saving measures built into the system when it's in gold trap mode, and you have a choice of 2 auto samplers with this system, or you can run in manual mode. So some more about this system. The detection limits are less than 0.05 nanograms per liter in the most sensitive mode. For EPA 1631, 25 mils a sample, you can get 0.05 nanograms or less per liter in detection. 245.7, a 10 milliliter of sample is less than 0.1, and you can do this in 90 seconds. And a usable range for this system is 0.05 nanograms per liter to greater than 400 micrograms per liter, or ppb, with no hardware changes. Not all in the same calibration, but that's a dynamic range for the system. So the patented gas liquid separator. Center post design, there's a large reaction surface area to liquid volume, rapid evaporation of the mercury, in the system, and that will increase the efficiency, and then it also increases the throughput because there's no carryover. So then there's a stable liquid film, and that stable film of liquid as it flows over the gas liquid separator center post, that is responsible for reproducible signals. And when you have reproducible signals, you have precise results. And when you have precise results, then you end up with ultra-trace method detection limits. The system also, it's non-bubbling with that gas liquid separator, so it's constantly removal of liquid, so it basically operates empty, and has fast recoveries for over range samples, say 1 ppm, can clear out in less than 4 minutes. It's non-foaming, so biological samples won't foam in the gas liquid separator, and you don't have to add any foaming agents. Since there's no residual level of liquid in the system, that's why it doesn't foam, and the mercury is just swept efficiently out of the gas liquid separator. So the detection for this system is by a photomultiplier tube. We also have lamp stabilization, thermally stabilized lamp compartment. The carrier gas is computer controlled, and it's argon. As you know, other gases in atomic fluorescence system will quench the signal, so you should only use argon. Oxygen and nitrogen can reduce the signal by as much as 30%. You also have easy access to the gold traps. So if you look on the system right here, there's just a door that opens, and behind that door you have access to the gold traps. You can just pull them right out, inspect them, and then change them. So a little bit about the theory. The QuickTrace M8000 is designed on, like I stated earlier, 1631 and US EPA 245.7 and other atomic fluorescent methodologies. Applicable methods typically require some type of digestion, whether it's ambient room digestion or a heat digestion with other types of chemicals to ensure that the mercury is in the +2 phase, but typically a digestion is required. So you digest the sample, you get it into the 2+, then you reduce it. Reduce it with stannous chlorides or sodium borohydride. Either one. Typically, the global market has migrated over to stannous chloride. Sodium borohydrate does tend to liberate a little bit more water vapor, so it would make the Nafion or the drying system work a little bit harder. But either one is fine. Incident light source is 253 nanometers, 0.65, and the signal is measured at 90 degrees from incident. So this system is a valve-based system, so it's a valve-based atomic fluorescence analyzer, and it allows you to determine total mercury with or without concentration on the gold traps. So you can, and with that said, you can use either one or two, but basically one of the reasons there's 2 gold traps in the system is because that was the original intent of 1631, to use a sample trap and then a common analytical trap, so the peaks and everything would be identical. Basically, the mercury will be swept out of the GLS, and it can go through a soda lime dryer or directly in the Nafion, and then you can go to, it goes to valve 1, and from there it can be directed to the gold trap or the non-gold trap, and from there the valves can switch to go to the detector and or to the waste. So it's all one system, and it's point and click in the software if you want to use gold traps or non-gold trap and straight up fluorescence. So an acidified sample is introduced by the peristaltic pump, and again it's mercury 2+, and dissolved in solution. And then at the same time you can use, we have double mixing key, so you can introduce hydroxylamine hydrochloride, and this is for 1631 to reduce the bromine, and then we would add stannous chloride later to reduce the mercury. So again, the reducing agent we use and recommend is 10% stannous and 7% HCl. And that parallel channel introduces that stannous, and then it mixes in the second mixing T here, represented by this number 3. Then the liquid mix from there travels into the liquid mix tube or the reaction tube, and the stannous chloride at this point starts reducing the mercury to elemental mercury. And that all happens while it's heading toward the gas liquid separator. And it's a fine dispersion of metallic mercury within this liquid in small, tiny droplets, and then you have excess stannous chloride. So the finely dispersed metallic mercury in excess stannous chloride is introduced to the top of the gas liquid separator, and then it flows down over the center post, and then it covers the whole post. So it's a very thin film of liquid, which is very efficient due to the mercury atoms being exposed on the thin film, and then the gas can efficiently sweep them off to the detector. So at the same time that's happening, your gas comes in tangentially on the bottom, right over here, and then it flows up and out. So then that gas swirls around the liquid gas liquid separator center post, and it sweeps all the mercury very efficiently off to the detector. These systems are, with the patented gas liquid separator, it's more efficient and works much better than a bubbling type system for a number of reasons. You don't have bubbles coming through, so it works on fish tissues and different types of biological samples that normally tend to be somewhat like soapy, and they'll bubble in the gas liquid separator. So then that's the mercury is swept upwards and out of the GLS and heads for the Nafion dryer right here, number 6. Then the dried gas is directed to either 1 or 2 optional gold traps that capture the mercury while letting the other gases pass through, and they just vent off the waste. The gold traps are then heated to release the elemental mercury. And then finally, that dry mercury is swept by the carrier gas, and it enters the sample cell, the quartz sample cell, and the fluorescent measurement by atomic fluorescence at the detector, position 9. And then all of the spectator ions in the waste come out the gas liquid separator, and they go to a waste reservoir, and the elemental mercury is swept out the back through the exhaust trap, and we actually trap that in a potassium permanganate vapor trap, so that reduces the mercury back to mercuric oxide, and the manganese is reduced. It oxidizes the mercury and reduces the manganese, and it efficiently traps the mercury. So I have a typo. This should, no, I don't have a typo. Never mind. So the QuickTrace M7600 and the M8000 atomic fluorescence, they both utilize the QuickTrace software platform. The only differences between the software is a couple of UIs. So the method editor, analyzer section, and the instrument analyzer UI. Those are a little bit different, and then also specify hardware, and so there's slight differences, but the software basically functions the same. So if you have either system, then you're very familiar with the software. So peak area, all systems, all analytical modes of operation, and then also you can define the blank acceptance criteria for US EPA 245.7 and 1631. Different regions have different discharge limits, so this is all called out for in EPA 1631 and 245.7, so you can change that so you're not locked into the absolute cleanest blank acceptance, and so this reduces a lot of that stress when you're running those methods and when you have to report to MPDES. Overrange protection, so it aborts the sample and then smart rinse is enacted. on-the-fly sample edition, so priority samples, so you can enter that into the sequence on the go. You can also export results directly to a Word or an Excel document while the system is running. So if you have noteworthy research and you want to start quickly making pie charts or whatever, or get it reported to a client, you can do that. So it's useful when on-the-fly results matter. So software overview. So you open the executable file. The software always opens up to the sequence editor UI. On the bottom of that page, there's a warm-up timer, and that allows the lamp and the optics to equilibrate, but you can bypass that if you want to. So you just click on it, and then the dialog box pops up, and you can bypass it if you don't need to warm up the system for the full time. But it's kind of a nice feature to have in the system. So the software is designed by the customer for the customer, so we're constantly taking feedback. And over the years, while we built the QuickTrace software, we're now on platform 3.0, and you have multiple ways to accomplish the same task. So you have the drop-down menu, you have the favorites bar, and then also within the software, you have pop-up menus. You can either right-click or left-click, and menus will pop up where you can do other things within the software. So it's very efficient and it's very fast to use this software. So what I'm going to do is I'm going to come across the menu bar and give you a quick overview of the menu bar items, and then we're going to go into the favorites bar. And throughout this, I'll be talking about pop-up menus and different things like that, and pointing you towards tricks and shortcuts to make your experience a little bit better. So basically under the file, this is some basics for the system. You create a worksheet, you can open, save, you can do new from scratch, new from existing template, new from and an existing template, create a method and then save it as a template, and you can save as. Save as retains the calibration correlation from an existing worksheet, and then you can import and export sequences. And then there's a lot of basic stuff in there, printer setup, open, last use worksheet, and et cetera, et cetera. So basically what happens is you have a worksheet and you save it, and it has all the timings that you need for that method, whether it's some standard method or an EPA low-level method or maybe a European Union method. Every time you run the system, you would go new from that worksheet. It will pull in all the timings, the calibration features, everything that you have to make this conducive to a good run, and then you basically just import a sequence and press go. So import the sequence from the LIMS system, or you can type them in, or you can create it yourself. So it's very simple to operate this software. The edit, now the edit, that's associated with the sequence editor user interface, and it has tools to help you with manual sequence input, and then you can copy, paste, insert, select, and different things like that within that drop-down menu. View just toggles between the sequence editor and the results analysis UI, and you can also access those from the favorites bar. So here is the sequence icon on the favorites, and over here is the analysis icon on the favorites. So right now there's two places where you can get to those user interfaces. The log is a data log, and on the analysis page, bottom left-hand corner, is where the log shows up, and this records everything that happens during that method. Stop, starts, raw data. You could put screenshots in there from the peak profile. Any access of operator's notes or anything you want to add, you can put in this section. So it can also be accessed from the analysis UI by a right-click. So you right-click there, and the little pop-up button shows up, and there you can do a log entry, filter, or add a comment. Same thing up here under the log from the menu bar. So the add comment, you can capture and record any unusual events, anything that you find that's important. So this is kind of working toward like a CFR 21 type compliance with the software. And you can click on the tab for the pop-up dialog, date, timestamp, and operator information. So you click on the little tab over here and that will pop up. Add a comment, you can type anything you want and say okay, and it goes into that section of the software. Analyze on the drop-down menu, on the menu bar. This will start a single read. You can also use the start run or the hotkey, and you can stop immediately or after sample, and then you can also auto zero. When you bring that up in a single read, there's a little hot button right here. If you click on that, that will open up the auto sampler guide. So then you can just point and click within that guide and it will go directly to that sample. You give it a name and it'll go right to that sample. So it's really, really easy, or else you can type in the location of the sample tube itself. So I use point and click a lot. On the menu bar, the options, now we get over to options, so there you can show auto sampler guide. So that shows up on the sequence editor on the bottom of the UI, and it's a really nice feature because it's all color coded. And you can also print that, so you can take it to the hood and you can load your samples and your standards in according to however you set it up within the user interface. So it reduces some mistakes by having samples transposed in the wrong position. And then also you have preferences. Preferences is a system-wide defaults, and under there you have calibration, file, location, report, and standby. And then you also have administration. So administration is user access management, where you can define certain rights for certain users within the software. So we're going to start on preferences real quick. So again, this is system-wide defaults. Calibration, if you click on there, you have the option to show concentration, and if that's checked, it'll display over range or O\R for any sample that's above the range. And then you can also lock that worksheet. So once results are collected in that worksheet, you can lock it. And if you have the administration privileges for the system, then you can lock it so none of the analysts can make changes to that worksheet once you've collected data. And then under the file locations, this is where you would set up your worksheet files. They can be anywhere on the server. Where you want to export them to, you can export them up anywhere on the server, typically to the quality control manager that's operating the LIM system, and also your template files. They can be held anywhere on the server, or they can be locally on the operating system as well. Options, preferences, so the report, in that section you can enter your laboratory name, and that will be displayed on the very first page, the header of the report when it gets printed. And then the standby, these are end to run features, so you can click on pump slow or off, lamp off, or gas off, or any one of those in any combination, and that's what will take effect once the analysis is done. We also have an enable inactivity, so you can set it up like it's screensaver, so you can, if 10 minutes, 5 minutes, 30 minutes. So if you got called to a meeting and you're not quite ready to go, if you have this clicked, it's going to put the system into whatever standby features you've clicked on the top, and you can save reagents and rinse and chemicals. And then also we have a rack separator that's set up over here, right there, and you can change it to anything you want. And here I've displayed using a colon and then a back arrow pointer, and then how it works. So if your operating systems have issues with, say, using colons or commas instead of periods and different things, this is where you can change it. This is more for the international computers and so forth. And if you want to allow loading samples on the fly, then you have to have this check. Allow editing of the sequence in progress. You check that, that's where you load samples on the fly during the run. You can add samples. The window menu on the menu bar, this is where you can jump between different UIs. You can method editor, sequence, auto sampler, parameters, reporting options, notes, and instrument, and view results. So the review results would show up over here. It's a peak in a graph and all the raw data and values for every single sample. So as you notice right here, this is the drop-down menu. So here's the favorites bar. Everything is also right here on the favorites bar. I typically don't use the favorites bar or the drop-down. I use the pop-up menus throughout the software. Typically, that's how I operate it. It's very fast and very efficient. On the help, that's typical HTML format, and the splash screen, that'll show the software version, and it also displays information on the system. So during setup, you can type the serial number into the specify installed hardware, and that will show up here on the splash screen. So if you want to call technical support or application support for a question, typically we will ask what system you have and the serial number and so forth and version of software. That's all displayed right here. And then it also has some legal notices, and everything will be displayed. So it's a quick place to get the information to relay to the technical support people. Now we're going to get to the favorites bar. So here we have file, and this is a shortcut for basically everything you need to do within the system when you're opening a worksheet. So you have new, from, and open. So new creates your own worksheet from scratch. New from will use an existing. Like I said, it will pull in all the information, the timing parameters, the heater parameters, everything that's associated with that worksheet. It'll pull it in. You basically give it a new name and save it, and you're ready to rock and roll. Open will open a worksheet anywhere at any time, and you can review it, or you can use it as a template. New, so this feature, like I said, will open a worksheet from any location, and it's a brand new worksheet. So new doesn't have any timing parameters built into it, so you have to create those yourself. But this is the only place where you can get quantitative or detection limit. So a detection limit, we have some basic default detection limit parameters set up in the system. So if you choose that, then once you say OK, then it takes you to another screen, and then you can choose the detection limit or method detection limit that you want to run on the system. So that's all built in, and it will display the MDL or IDL at the end of the run for that particular detection limit and method with gas flow and pump rates and so forth. We also have a fair number of CAN templates that we built into the system as well that you can use. So new from, this feature opens a dialog box where you can browse or type in the template to recall it. You can save it as a new name, and then you basically load the sequence and hit go. So again, this is new from, has all the timing for the system. Everything's all set up. You have no worries. So new from templates. So we've created a fair number of templates for the system under each scenario and each applicable method. So standard method or US EPA methods for 1631 or 245.7 and choice of auto sampler. So we've gone through and tried to create some of these, and it's a good way to get you started in method development without a lot of the headache. So all the systems come with these canned worksheets. So here's some basics. So you can save the worksheet, you can print the active worksheet, and you can do a print preview. So these are right here on the favorites bar, straight up and looking at you. Reports. Now this is, you also have in the reports, you have printer set up. So there's another place where you can do that. You can also do it under the main file menu. You have printer set up there as well. You can print and or export from here also. So you open up a worksheet, choose for reporting, report settings. You can change any of the settings within the parameters of report settings at any time. Everything is saved 100% of the time. So you can change decimal places, you can change significant figures, you can change the objects that you want to report within that worksheet. The sequence editor. So this is, when you get into the sequence and the method editor, this is where a lot of the stuff happens, a lot of the neat stuff for the software. So here you can enter samples if you're not using a sequence wizard, and I'll talk about that later. So there's an automated sequence wizard you can use as well. Here you can right-click. So when you're on that screen, if you right-click, then you have a pop-up menu. So here you can copy and paste, insert rows, auto-renumber, resequence, import samples. You can export sequence, print labels and so forth. So it's a really nice feature, and you can show the auto sampler guide. So there's already like 3 or 4 places through this software where I've shown you where you can get to the same end. On the top here, you can change the global weights and volumes for that worksheet, or if you click on this little hot button, then that opens up this feature down here, and then you have units of quantitation, units of weight, or units of volume, and you can change these and create your own if you want to as well. So when you're in the sequence editor, if you're under the tube section and you highlight and right-click, you get a little pop-up icon with some little dots on it, and if you click on that, that will open up the user guide for the auto sampler. So then you can just point and click, and that information then will get dropped into this tube line here. So it's really easy. You don't even have to remember what the tube is. You have a visual. You can just look at it and go from there. We also have fill down, and there is just a number of things on this sequence page that are very, very, very useful. And here's a highlight of some of the things you can do. I exploded this. You have sample weights, prep volume, aliquot volumes, dilution volume, dilution factor, and then spike volumes. So there's a number of things you can enter in with this sequence. So on the favorites bar, that in sequence editor, it, like I said, is very interactive, and it's an intuitive software package. So if you right-click, you can import the sequence from the limbs. And this is a quick wizard. It walks you through step by step, and you can move the columns around to make them associated with however your limb system functions. And then you can save that at the end as the template for importing with this direct limb system. So the next time you want to import, you just open it up and you go next, 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 boom, and it'll populate the sequence. And then it'll also load up the auto sampler guide with the color code so you can see what the samples are and where they're located. Under the analysis results view, you can adjust the window sizes, and you have right-click in any one of those screens and you get the pop-up menu. So here you can jump between the different UIs, and you can go to reports, administration, you can view results, you can delete, or you can copy. When you click the copy, that you can copy all the results in real time and export them to a Word doc or an Excel document. And all of our graphs are interactive, so you can zoom, you can right-click, you can left-click, you can move the graph all around, you can look at the baselines, you can unzoom. So, and while they're happening, real time, you can move them around and view and unzoom in those graphs. So you can get a good look at the baseline or the peak height or the plateau or anything with the method that you might need to look a little more closely at for troubleshooting. Double left click in any one of these sub UIs within the analysis will get you full screen. So then you get full screen of that UI. You can then you have a better view of a graph. You can inspect your calibration data and so forth. A lot of nice features embedded in this software. Under method editor, so this is right up here. It has the little Erlenmeyer flask on it. This is where all the basic functions for that method happen. You can file, save, print graph, and then you have tools. So the tools, you can define units and standard names. So this will be the second place where you can do that. You also can make that happen on the sequence UI. And then you have your conditions. So the conditions here are the auto-sampler and analyzer conditions for the timing, method settings, and so forth. And then you have standards. This is where you enter in the standards and the concentration and the position. And then you have your QC rack tests here right on the end. And this is for quality control, concentration, and limits. So this is what happens when you go into tools and define units. So here you have quantitation. You can use existing what's in here, or you can create your own. This is, we use this for, say, clinical labs where they may have like millimoles per deciliters or milligrams per deciliter, and whatever reporting criteria they have within those type of laboratories, you can create those here, and then you can save them. So you can define your own units. And then standard names here as well. You can change your standard names and save them, and that's what's going to show up on the worksheet. So then defining units, again, you got units of weight and units of volume. So you can put in pounds if you want, whatever you want to put into this software to make it conducive to your region and how you operate systems, you are allowed to do it. It's very intuitive, very versatile software setup within this QuickTrace. So the favorites bar, method editor. So under conditions, this is where you have the sample, auto sampler, rinse, and uptake time. And then your analyzer settings. So this is where you have the method timing, settings, baseline correction points, integration, replicates, your gas flow, and your pump speed, and so forth. And then also the icons on top of the graph. You can toggle between grid lines, copy to chart, print, unzoom, and so forth. You can take the peak profile and drop it into the log, stop, start, zero, and neat features like this. And this is where you would do the peak profile to check your timing and to adjust it. So under the standards page, this is where you set your calibration type. So you can have normal, EPA 1631-245-7. Your quantitation mode, so you can peak height or peak area. Your algorithm can be linear or quadratic, and you enter the standards concentration, number of standards, and rack position. Also on this one here, and then on air, you can continue, stop, or flag and continue as well, and then that's for the air actions down here. Also on this, you can email yourself. So if there's error or you want to notify yourself at the end that it's done, you can set up an email. So the system will actually email you, and you put in your mail format, your mail address, and if you check that box, it'll email you. So you can get it on your iPhone, you can go back into the lab. It is really, really a nice feature. Specify limits on the bottom of the QC test. This is where you enter in your concentration and limits of the system. So when you specify limits down here, percent replica, if you check any of these, for example, if it's above 5% and your HF units are above 1,000, it'll give you an error. If it's below 1,000 and above 5%, it doesn't care. Same thing for these other ones. If you check them and it's above that concentration, whatever you put in there, then it will report that out in the report as greater than or equal to RDL or greater than or equal to IDL. The sequence wizard also does the sample count, so that's this icon over here. You can start with your position. You can add prefixes, IDs, and suffix, in your ID increment, sample weights, volumes, insert a calibration. Click Generate Sequence, and it'll populate the sequence page. On the sequence wizard, once you get into the auto QC function, these are drag and drop. So if you grab some of these features, you can drag them over here. You set your parameters, whatever you want, so flag and continue, whatever, and you drop them into here, and then that's an automated QC. On the bottom for auto QC actions, this is where you create your own. So it's yellow tests up here, green in the middle, yellow and green on the bottom. So this is where you would do throughout your every 10 samples, read a QC, every 10 samples, do a spike, and so forth. It's very easy, drag and drop, right click, and you can set it up. Manual QC on the back side of this wizard. These are the error functions you have. Manual QC is associated with the sequence page when you insert a sample or a concentration or a test by itself right here. That's when these will take precedence and use these error actions for this. That's manual QC. So it's again manual insert of the QC into the sequence wizard. The auto sampler, this is where you define your racks right here. Click on this and it defines your racks for the method. So within the software, when you're running, you can have any different rack you want with any different with the different tubes. This is an example of the 4-rack auto system. So if I wanted to have a 21 position here, a 60 here, a 90 here, and a 40 position here, that's allowable. The software doesn't care because you define it and you set it up and go. So this helps when you have different digests with different volume size, and maybe you have to split a sample, so you might pour it into a smaller tube, and then the split might go to another instrument, an ICP-MS or so forth. But that's a nice feature as well. And then on the sequence parameters right here, this UI, this is where you set up smart rinse values, overrange values, standby, and the run analysis. You want to pump off, pump slow, and so forth. And then also, if you want to be notified at the end of the run, you can email yourself here as well. So you can send an email, and you can print it, or you can send it right up to the LIM system if you want to. Reporting options. So the active worksheet, you can change reporting options at any time. Change the content number format. So you can decimal places, significant figures. You can auto report at the end of the run, none after run, or export, comma delimited, or text file, or to a printer. And then under notes, this is a nice feature. So if you're using new from, the notes would be attached to that worksheet. So the analyst can open up notes and look for anything that may indicate they might have a problem with certain samples, maybe digest this sample for 2.5 hours instead of 2 hours. And then the menu up here, you can delete, cut, copy, and paste. So it's a nice feature. And then we have hot buttons on the menu bar. So here you can start the run. You can read a single sample. That's the second place you can do that. And then this little UI pops up. You can zero, wet the gas liquid separator, set gas and pump rate to match method. So if you pop between different methods, you click on that icon and it stabilizes the system to match that gas flow and that pump rate for that method. You can automatically have it go into standby, click to move, and it takes those features from standby and implements them. You can go directly to the help, and you can add an entry to the log right here. Another nice feature about this too is you can, if you right click on the favorites bar, you can grab and move any of these things. If there's a small little button right here, you can rearrange them. So you can move them around, rearrange them, do however you feel comfortable with this favorites bar. If you use, say, the help file a lot, well, maybe you might want to have that over to the left. It's entirely up to you. So there's a lot of nice features within this favorites bar that you can utilize. So in the favorites bar, then the instrument control, this is way over on the end. This is for diagnostics only. You can move the probe, change your rinse pump rate, and do things like that. You can change the Pmt voltage, or you can use and do an auto select under the analyzer section. You can stop and start strip chart recorder, turn your lamp on and off, and a lot of things for diagnostics and or troubleshooting. This has no bearing on the methodology. This is only for diagnostics. The methodology all takes place in the sequence UI and the analysis or the method editor UI. And then under instrument control, a maintenance log here. So if you want the serial number to show up in that section, you would enter it in specify installed hardware, and then it would show up here. And that's another place where you can look for it instead of the splash screens. But it would show up there as well. And then you can also record events. So anything that happens, any maintenance, you can record it, and you can create your own. So you can add a comment. And this is also on the favorites bar, add comment directly into the instrument log. Now, some quick tips on method setup for ultratrace analysis. And I'm going to have a following webinar, which I'm going to kind of lead in, a little teaser here, was going to be more about method development, how you actually do things on the instrument. This is to get you familiar with the software and some basic functions here. So when you're running an M8000, especially in gold trap, you need to clean up the carrier gas, because there's about 4,900 metric tons of mercury that's off-gassed into the atmosphere every year. Most of it is anthropogenic, but some of it's natural as well. Anyway, so when they distill the gases, they take it from atmospheric gas and distill it down so that mercury ends up in the argon. So we have a proprietary trap that will collect the mercury, and it runs up to 20 milliliters, 20 liters per minute is its max. You can use this on other instruments too. For example, if you have a laser and you want to remove the mercury from the gas from that system, you can use it there as well. You could use it for your ICP, ICP-MS to clean up that gas. But what we do is we have that as a pre-filter, and then we use a gold trap that's downstream from that, and we check the gold trap every time you run the ultratrace method. You want to check it for breakthrough. We've been running on a system here for a couple years. We haven't seen any breakthrough, so the capacity of the pre-trap is really high, but typically you can only clean the gas up to about 0.03% of a 100 nanogram per liter response. That's about as clean as you can get it. But you need to put these features in place if you want to do gold trap analysis. In gold trap analysis, you want to follow the strictest good laboratory practice, GLP. So you always want to wear gloves, and you clean as you go. And when I make standards, I use what I call a lid on, lid off technique. So I start from the lowest and work my way up to the higher standards. Have everything ready, everything's written down. I have all my pipettes and everything all ready to go, so I'm not dashing around the lab trying to complete the task. So it's when you get down into this level, you need to make detailed notes and really pay attention to what you're doing when you make standards and or samples. So what I do is I will add the water or a weak acid, and then I'll add the standard aliquot onto that, and then above that I'll add the digestion reagent. So every time I do an addition, the cap to the test tube or the volumetric flask, whatever you're making the standards in, it's always nearby, and then I pop it on to preserve that in between additions so I don't contaminate anything. So a little bit about method development. So what affects the dynamic range in a continuous flow system? So high flows will equal short residence times within the detector. That gives you speedy results, but it also decreases the sensitivity. If you lower the gas flow, that will increase the time in the detector. So that increases the sample times and sample rates, but that will increase the sensitivity. Pump rate increases or decreases the time to the GLS and mercury load onto the gold traps. And then time in sample, that will increase or decrease the sample load, and you adjust that to hit a steady state if you're running non-gold trap for the signal plateau. So those are basically the functions that you can use straight away when you're working with method development, is gas flow, pump rate, and time in sample. And it's really, really easy because in our method editor, there's the one screen where you do peak profile, and you can view it, change your settings, and it will display a new percent RSD for that sample, so you can see everything take effect in real time. So again, you adjust all these settings with or without gold trap to achieve the desired results. So basically though, in in all modes, the sample time plus rinse time must be equal to or slightly greater than all of your combined timing parameters. So to determine dynamic range, in non-gold trap, the range is 0.1 nanograms to greater than 400 micrograms per liter. And gold is 0.05 to, you can run up to probably about 10 micrograms per liter, and that's by changing the parameters, the gas flow, the pump rate, and so forth. And you want to look at your historical data. So what data came from the customer, and then how do I need to develop these methods? And it could also be based on sample volume desired, or maybe it's available sample volume from the digest. So that's how you would set this up. So you change the gas flow. If you notice here, it's GLS flow, low to high. So you can dial that in for the most desirable response. Again, slower pump rate will lengthen the analysis time in non-gold. Less sample uptake shortens the peak response plateau. So you want to balance all these with the response you want. Peak area can also be part of this discussion. So then you can run really, really fast, and you don't have to have a plateau because you're going to measure everything under the curve like you would with gold trap. So you can make the changes on the highest calibration, make adjustments, achieve the desired results, and repeat, and then run a calibration. In gold trap, now if you notice here, it changed from GLS to purge gas. So now we're in gold trap mode. So you basically click the gold trap checkbox, and the first one will be highlighted. And now you have purge gas rate and then time in sample. That's what's going to affect your load. Pump rate, not so much. It's best to load as fast as possible to reduce that portion of the analysis time. So I always load at 100%, and I adjust my load by time in sample. And one more thing that you can change with this, it's a little known feature, the Pmt voltage. You can adjust it yourself. And if you adjust the Pmt voltage down, that gives you a lower response per atom. So then you can increase your dynamic range. So this is one of the features we use to get up to 400 microgram per liter in the non-gold system. And you can also use it in gold trap mode as well to get up into the ppb range for gold trap analysis. So the low flow would be typically for 0.05 to 1,000 nanograms per liter. And if I want to use high flow, that's where I want to get into the microgram per liter range with gold trap. And then you adjust the time in sample to give you the desired load, and that's going to change your peak response as it desorbs off the gold trap. So peak profile, your highest standard, you click on here, any mode of operation. The graph is going to show up here. You're going to adjust all these parameters, and it will change your peak area response, and you can zoom in on the baseline and go forward. You like it, save it, and then enter your standards, import your sequence, and you're off and running. To use a second gold trap, you just simply click on the box. Click on the box, it highlights that, and now you have the second gold trap analysis. There's really no benefit between 1 and 2 gold traps. It just adds time. Typically, you'll get the same response because we're just desorbing one off to the other. The only reason we have it in there was because 1631 was originally written for 2 gold traps, as I kind of alluded to earlier, but the method is now performance-based, so you don't need it, but we kept it in there just because it was in there from the start. And then if you want to use 2 gold traps for some reason, then you have that option. So this is a typical 100 nanogram per liter peak. This is what it would look like in gold trap. So here in the front part of this peak, you see this little bump up. That's real time. So we monitor it in real time, and then we run a cut time where it switches the valves. So this real time allows us not to load any air on the gold trap. So you load the system when the sample probe is only in the sample solution. It doesn't get any air from the from the probe moving to and from the sample, or to and from the sample back to the rinse. So it's only loads a pure sample. It's really a nice feature, and this will be explained later in the next webinar. So some typical gold trap data based on when you optimize the system. Now here is a case where we optimized it for ultra trace detection limit, and this is 1631. So we used EPA 136 Appendix B for the MDL, where you run it at one level and then you run it at a second level and it calculates the MDL. Here our MDL is 0.053 nanograms per liter. That's the MDL. Here's the responses. So this is a 1 ppt, so it's almost bang on with very little variance at all. 04, 03, 02, 01, 01, 05, and 05, and then we ran a 25.25 ppt, so 26, 24, 22, 23, 26, 27, and 28, and that is stability that you will not find in any other system. And one of the reasons for that is the way we run this ingenious cut time. So we only load when the probe is in the sample. So we almost created a flow, a continuous flow, and we've turned it into a flow injection. So it works like almost like a flow injection valve is the way we set it up through the state diagram that changes these valves. Just some quick graphs here of typical data. So here's a Lake Superior fish tissue, 2 ppb in solution. The response was 4.33, and we achieved 4.08. So it's a little outside of the range, but the fish might have had some extra moisture or that we picked up or something during the analysis. But this is just an example of some of the dynamic ranges. Here's coastal seawater, and the calibration is non-gold up to a 10 nanogram per liter. Now here's some of the dynamic ranges of this system. So here we're running up to 150 ppb with the solution, with the sample in non-gold. 80 ppb is what the sample read in solution, and the results, the CRM was 32.6 plus or minus 1.8, and we achieved 32.3 plus or minus 2.5. So very nice results with a system in high dynamic range. So in closing, the QuickTrace M8000 method development is quick and easy. It has an amazing dynamic range, and the manual and help guide is really, really easy to use with a lot of pragmatic tips on method development. And it also, the manual also has an extensive section on maintenance for daily, monthly, and yearly. So I'm going to tease you a little bit. So coming up, we're going to have, I will have another a webinar here shortly, and that's will entail startup, shutdown, dynamic ranges, and how do I actually develop those with real data. And so method development for ultratrace to microgram per liter, and I will talk about 1631 and 245.7 method compliance and how that works within the software. And then I will move into some of the basic maintenance, troubleshooting, and repair. And with that, that's going to conclude the presentation section, so we will open it up for questions.